Good morning, sir.
Hello, my dear students. Good morning.
Good
Good morning.
morning, sir.
Yes, yes, yes. So, how are you all doing? Exams got over? Midterm exams?
Yes, sir.
Yes,
Okay.
sir.
How are the exams, people? Is it good?
Yes, sir, I did well, sir.
Good, good, good. What about others? Ashta, Fuja, Aditi, Sanya, Durlav, Amrita. How are the exams? Especially science exams? Guys, are you there? Not nobody wants
Yes,
wants
sir.
to
I
come.
did well, sir.
Good, good, good. Okay. Right. So we have completed three chapters for you. For everybody, the exams are over, right? Is there anyone who still has exams going on, or still exams are about to come? Anybody is like that? Okay, right. I hope for everyone the exams got over, right? Okay, so if that's the case, people, what we'll do today is basically we'll start a new chapter. Okay, so you have only two more chapters left, right? And we have a lot of time, right? So we'll take it very slow. Okay, and if possible, then and there I might give you extra information also, which is going to be helpful for you in your 11th class. Okay, so why am I telling you this is 10th, obviously 9th and 10th are going to form the base for 11th, right? But again, when you go to 11th, right, you will find that there is going to be a huge jump in the number of chapters, the amount of content you have to read, right? All those things will have a huge jump. Let me give you a small scenario also. Now, what exactly will happen is this, right? So now, in total, in science, how many chapters you have? Tell me, including physics, chemistry, biology. In science, how many chapters you have? Roughly, like not the exact number.
16, sir.
16 chapters, right? Okay. Now, when you go to 11th class, right? So you see, together science, sorry, that is physics, chemistry, biology, together 16 chapters you have, right? When you go to 11th, chemistry alone, I have 13 chapters. Okay. And physics alone, that again, there is not anymore science as a common forum, right? You'll see that physics is separate, chemistry is separate. I mean, if you're going to take biology in 11th, biology is separate, right? If you're going to take computer science, again, that will have so many chapters. So physics alone or chemistry alone will have 13, 14 chapters, right? And you will have two books for chemistry itself, part one chemistry, part two chemistry. Same goes with physics, right? Part one physics, part two physics, right? So now you see, you understand, in science alone, you have 16 chapters and 10th. When you go to 11th, you will see that in chemistry alone, I have 13, 14 chapters. Physics, same thing. Biology will still have so many chapters. Biology, I don't know. I think I know it's more than 20 chapters in 11th alone. Same goes with 12th, right? So now for you to, correlate, for you to adjust, when you go to 11th, it will take definitely 2 months for sure. Any 10th student going to 11th, for him or her, it will definitely take a good amount of time for you to get settled, right? For the level of concepts, because like our system is like this. Okay, they should have included so many other things in your 10th class itself, right? But this thing is like this. But anyways, this is how we have been. Give me a moment. Yeah. So, okay, right. So, and most of the chapters you will see in 11th, right, are going to be from, say, continuation of 10th class. Say, for example, there'll be a chapter called as equilibrium, right? So that will be, I would say that will be a continuation of chemical reactions and equations, right? And again, in equilibrium, I can say it is a continuation of acid, bases, and salts, right? And when you go to periodic table, now you're going to see periodic table. Periodic table, you will see that again, I have another periodic table, same periodic classification of elements, same chapter will be continuing in your 11th class also. But again, whatever you study here will be little minimal. There you'll study so many things. Okay, right. So, and again, obviously the last chapter will be carbon and its compounds, right? So for carbon and its compounds, again, you'll see 2 organic chapters, right? 2 organic chapters you'll see in 11th also. Okay, fine, guys. So I think we'll start right away. Okay, which chapter you want to start? You want to start periodic table, or you want to start with carbon and its compounds? Which chapter you want to start? Any suggestions? Anybody have? No suggestions? Yes, do you want to start with periodic classification, periodic table, or you want to go for carbon and its compounds? This is really killing me. Okay, fine. We will start with maybe carbon and its compounds. Okay, periodic table will keep it at the last. Okay. In your school, did they start anything, people? In the school, have they started any new chapters for you after your midterm?
No, sir.
Nobody, no school started. Okay, fine. So then we'll start with your carbon and its compounds itself. Very interesting chapter. Then we'll come back to periodic table. Okay. Right. Fine. So today we are going to start with carbon and its compounds. The chapter name. Okay, right. So the first question is, why do we have to study about this particular element, carbon? Right. There are going to be 118 elements. Now, like in the periodic table, right? There are 118 elements in the periodic table. Periodic table we didn't study, but not a big deal. All you have to understand is, till now, there are 118 elements discovered. Okay, fine. Now, if I have 118 elements in the periodic table, totally 118 elements are there. Why carbon is so special, right? Why is it that carbon is so special that it got a chapter on itself? Why don't I have silicon and its compounds? Why don't I have, say, magnesium and its compounds? Right? Why is it like this? Why carbon deserves, right? Why is it that carbon deserves a full chapter to itself in 10th class? Right? Okay, we'll answer the question. Because carbon is so special. Okay, carbon as an element is so very special. Right? Now, why is it special? We'll see that later. Now, what's like, say, how to put it? It is special because it has some property, right? But it does some magic. Okay, carbon does some magic. Okay, for example, we'll just take a human body or any living system, for example. Okay, any living system, for example. Okay, right. Say in our living system, all living systems are made up of cells. Is it not? All the living systems contain biological cells. They are made up of biological cells, right? And you might have known now, inside the cell, there are so many things: nucleus, mitochondria, Golgi apparatus, so on and so forth. So many things are there, right? Now, any component of cell you take, for example, you take cell wall, Okay, you take cell wall or cell membrane, for example. Okay, now that cell wall or cell membrane will be made up of something called as glycogen. Okay, you don't have to remember anything, just giving you an insight. Why is carbon so special? Right? So I told you the cell wall or cell membrane, right? What is that? It is made up of a chemical component called as glycogen. Right? So basically, see, I am trying to take you into the molecular level of living life. Right? So what I'm trying to tell you is, if you look at this glycogen, it is nothing but a compound which is made up of carbon. Right? So if I have to write the formula, it will be basically C6H12O6 N times. Right? So now what is this C6H12O6? Anybody knows? C6,
Glucose, sir.
glucose. Right? So your entire, basically, I would say glycogen is a polymer of glucose. Okay, basically so many glucose units, N times we wrote. Okay, so many glucose units will come together, make some kind of bond, and that is going to end up with glycogen. Right? So your entire cell wall or cell membrane is going to be made up of your, oh God, 1 second, people. Right. Okay. So what I'm trying to tell you is, this entire cell wall, right, is made up of glucose, which is nothing but a carbon compound. You see, there's carbon here. Right. Now, you go, say, for example, in our body, we have proteins, right? We have RNA, DNA, right? Your RNA, DNA would have studied. I mean, you wouldn't have studied, but at least you would have heard, right? Now, again, all of them are carbon compounds, right? Proteins, RNA, DNA, carbohydrates, right? All the sugar you eat, right? The glucose which is there in the body, even your blood, right? Even your blood is a compound of carbon. Right? And any tablet you take, right? Any drug you take, right? Drug doesn't mean bad. Okay? A drug, when I say a drug, when I take the drug, it should give me some biological response. The biological response can be anything. Right? So anyways, so any drug you take, paracetamol, that one, this one, everything will be a carbon compound only, some way or the other. Right? You will see that it is actually going to be a carbon compound. Right? Now, see, what you have to understand is, if I take the number of elements, number of compounds formed by carbon, okay, if I take the number of compounds formed by carbon, and I take the number of compounds formed by all the other 117 elements together. Okay, I'm telling you that I'm going to take carbon and I'm going to see how many compounds carbon forms, right? And I'm going to compare it with the number of compounds together formed by all these 117 elements, right? You will see that carbon is going to have more number of compounds formed. Okay, carbon is going to form more number of compounds than all the other elements put together in the periodic table. So versatile, so versatile. Literally, carbon can combine with any other element in the periodic table. Okay, carbon can combine with any other element in the periodic table. It's so special, so many compounds, and it is very easy to understand why is it that carbon is capable of such a thing, right? And from this discussion, from our DNA, RNA, this glucose kind of discussion, I can tell carbon is the essence of life. Right? A life without carbon is not possible. Okay? Everything in your body, from your skin to whatever the organelles is, if you go inside and to a cell, every component in a cell, right? Every cell wall, mitochondria, everything is made up of some amount, some kind of carbon compound. Okay? So that's why carbon is essential for our life. Right? Not carbon as carbon itself, but carbon in the form of some of its compounds. That's what you understand, right? So this is not an exaggerated statement, people. This is a very good statement. Carbon is the essence of life. Okay, right? So now you have understood why is it that carbon is so special? Your entire body is made up of carbon. Not only your body, any microorganism, bacteria, virus, fungi, or what you name it, plants, whatever you have, everything, anything which is living is made out of carbon. Okay, anything which is living is made out of carbon. Right now, when you go to 12th class, right, when you go to 12th class, you will study, there is the chapter called as Biomolecules. Okay, you'll study a chapter called as Biomolecules. Now you'll see, again, you'll study the same thing. You'll study about carbohydrates, you'll study about proteins, RNA, DNA. Basically, biomolecules means molecules which make up the biology of a living system. Okay, molecules which make up the biology of the living system, the metabolism, whatever. Right? You will see that all of them will contain carbon in some form. Okay, I can actually give you an insight. Now, this is about glucose, right? Now, say if I take proteins, for example, right? Now, protein will be like, I'll just give you the structure. I don't remember anything, right? Say now, one of the protein structure will be looking like this. Not protein structure, I would say a small part of protein will look like this. Again, you see everything is carbon. Obviously, other elements are there, right? But majority you will see it is a carbon. Right? Now, again, if you go to DNA or RNA, right? DNA or RNA you go, right? Again, you will see that I'm going to have a structure like this. Something, right? So what you have to understand, don't worry about the diagrams. These are all carbon atoms. The corners, which you see, all of them here also, all these things are carbon atoms. Okay, you don't have to remember anything here. All what I'm trying to give you is a flavor, right? Why carbon is so essential for our life. Okay, right. Not only that, people, any enzyme you have in your body, for example, say your saliva, right? Again, saliva is made of a carbon compound, right? So what I'm trying to tell you is literally anything which is there in the living system, almost 99.9999% of all the things that are present inside a living system or make up a living system is made out of carbon. Okay, so that is why we have a separate chapter for carbon itself, right? And I would say there's a separate branch of chemistry, right? So now when you go to 11th class, we will be segregating chemistry into 3 types. One is what is called as physical chemistry. Another one is what is called as inorganic chemistry. The last one is what is called as organic chemistry. Okay, you will study 3 different types of chemistry, all are chemistry only. Right. Now, physical chemistry will talk about the physics around chemistry. Right. So there will be a lot of physics involved. Right. You will have a lot of numerical problems coming in physical chemistry. Right. Now, forget about it. When you go to organic, this entire branch of chemistry is entirely about this carbon. Okay, this is entirely about one entire broad. See, now you are seeing only one chapter in a 10th class, right? But what will you not actually realize is an entire one branch of chemistry is dedicated to carbon and its compounds, obviously. Okay, now this inorganic is all the other elements other than carbon. The chemistry of all the other than carbon, all the other elements, whatever the chemistry they have, that comes under inorganic. So now you understand, for one element, I have an entire branch and all the other elements will come under inorganic. This is different, right? This is going to study about the physics behind what the chemistry molecules, or say some way how physics and chemistry are related. That kind of things we'll study. Okay, right? So now you understood what is the importance of this chapter. You will really appreciate. Okay, you will really appreciate once you get to know more and more and more about this particular carbon and obviously its compounds. Okay, right. Now, we understood why carbon is so special, right? What makes it special? What kind of properties carbon has, right? What kind of properties that carbon has that it is able to do all these stuff, right? I told you the number of compounds formed by carbon, you cannot even compare it to the number of compounds formed with all the other elements put together, right? Now, why is it that carbon alone has this property? Why no other element has this property, right? Why carbon alone is able to make so many compounds combined with all the other elements in the periodic table, but none other element as compared to carbon like that? Why? What makes carbon so special? Right? What gives it special abilities? Right? So we are going to see that. Right? So we are going to see what makes carbon special. Right? There, I would say there are 3 to 4 reasons, because there are 3 to 4 reasons I can give you what makes carbon so special. Okay? Right. The first point regarding this is carbon is a tetravalent compound, tetravalent element. Okay. Now, what do you mean by tetravalent? Oh God. 1 second, guys. Okay. Right. So I told the first reason what makes carbon so special, why is it able to form so many compounds, why is it the essence of life, is because carbon is a tetravalent compound. Right. Now, what do you mean by tetravalent? Valent, we know, valency. Right. Tetra means 4. Right. Now it's very simple. I know valency of carbon is 4, right? How valency of carbon is 4? Carbon, what is the atomic number of carbon, people? Atomic number of carbon?
Sir, 6.
6. What will be the configuration?
2,47.
Good. Right. So now you see carbon, okay, is having an atomic number of 6, and obviously it is going to have a configuration of 2,4. Right. Now you see there are 4 electrons in the valence shell. That is the last shell. Right. Now there are 2 possibilities, right? 2 possibilities for me to form octet. Is it not? What are the possibilities? I can have -4 electrons lost, basically 4 electrons lost. That is what I mean by -4 electrons. So the configuration will become 2, duplet satisfied, right? Or I can understand that I can add 4 more electrons to have a configuration of 2,8, right? So that again octet is satisfied, right? Now the question is, will carbon do this? The answer is no. None of it will happen. Right? Carbon is not going to gain electron. Carbon is not going to accept electron. Right? Carbon, what is it going to do is that instead of losing or gaining electron, it is going to share electron. Right? It is going to share electrons. We'll come back to this point. What do you mean by sharing? Right? Now, what you have to understand is, why is it that this is not happening? Right? Why is it that I cannot add electron, I cannot remove electron from carbon? Why is it like this? Can anybody come up with an answer? Why am I not doing? Why carbon is not able to do this? Any idea? Any guesses at least? Yes, anything you can think of? Why is it that carbon, basically what I'm trying to tell you is carbon cannot form ionic compounds, right? Carbon cannot form ionic compounds. But again, that's a very generic statement, people. You will find that carbon can possess some charge, but it will be in the form of a polyatomic ion. But anyways, we don't have to go into the details. So in general, carbon cannot form ionic bonds because it is not going to gain electron, nor it is going to accept electron. If it gains electron, it will form an anion. If it loses electron, it is going to form a cation. Right? It is not going to do none of them. Right? It is not going to do either of them. Right? Why? Why is it that this thing might not be possible?
The number of protons might be very high to support that many electrons. So the energy in the it might be high, sir. So it won't
Ah.
exist in that form.
Okay, yes, that's a good point, right? Now the thing is, see, I have to see the nucleus is there, right? And there are 4 electrons like this. Okay, 2 electrons here, right? Okay, now if at all I have to remove, see, basically for me to remove electron, I have to remove this electron, means I have to spend some energy, right? Now, why do I have to spend some energy is the question. Now you see, I have the nucleus, I have this particular electron, I know nucleus is positively charged, right? Nucleus is positively charged, electrons are negatively charged, right? Nucleus is positively charged, electrons are negatively charged. So obviously they will have some force of attraction, correct? Because positive and negative will attract, is it not? So obviously they'll have some force of attraction, right? So not only in this case, not only in carbon, anywhere, say if you have to make sodium to form sodium plus by make it lose electron, again I have to supply some energy. Okay, now this energy is what I would say, you don't have to remember this, but this energy is what is called as ionization energy. Okay, maybe you'll study them in periodic table, not in this class, but in 12th. Okay, so this energy, for me to remove electron from the valence shell, to overcome the force of attraction of nucleus, right, is what is called as ionization energy. Or all you have to understand is, for me to remove electron, I cannot just do it like that. I have to supply some energy. Okay, now for removing 1 electron, you have to supply energy. Imagine about a case where I have to remove 4 electrons. Lot of energy will be required, right? Lot of energy will be required. So carbon is not going to go down that path. I already told you when we spoke about chemical reactions and equations, right? A compound will be formed or any transformation will happen. We will make sure that it is going to take a path where there is minimum energy expenditure. Okay, anything you see in chemistry, okay, anything you see happening in chemistry, there might be multiple paths, right? Say for example, I have to reach from airport, say to central station, right? I have to reach from Chennai airport to central station, right? Now there can be numerous paths, right? Now I can go through Mount Road, I can go through, I don't know, like whatever, right? There can be multiple paths, right? But what do we choose? We choose a path where there is no traffic, right? Where it is going to take the least amount of time, or where say there is going to be good roads, like that. The compounds or chemistry also works like that, right? It also looks into all the possible routes and it is going to take the best route. Now, when I say a best route, right? A best route is one where it requires only very less amount of energy, right? So very less, I would say very less energy expenditure, very less amount of energy is spent in doing the process. Okay, so if there is one path is going to take higher energy, one path is going to take lesser energy, that particular chemistry or whatever the compound is going to take the path it is going to have lesser energy required. Okay, right? So obviously, since I have 4 electrons to be removed, lot of energy will be spent. So obviously, carbon is not going to go down that path, right? Then what can happen? This is going to happen. We'll see what is this sharing of electron. I think you know already, but still we'll just see. I'll just give you a quick recap. Right. Okay. Removal of 4 electron is not possible. Minus 4 electron is not possible. Removing 4 electrons. What about adding an electron? Why is it that I cannot add 4 electrons? Any idea, guys? Why is it like this? Okay, 4 electrons removed, 1 electron, I require a lot of energy. 4 electrons, I'll require a tremendous amount of energy. So this is not possible. What about this? Why can't I add 4 electrons to carbon? Any guesses?
That many electrons won't stick together in the atom.
That many electrons are already there in the atom. So?
No, sir, there are 6 protons. No, sir. So,
okay.
So if there are many number of electrons, they won't, the attracting force won't be enough to keep them in place, sir.
So which force is going to dominate? If attractive force is not going to dominate, which force will dominate? We are coming to the right point. So if attractive force will not be enough for what? So what force is going to oppose this?
Sir, the force exerted by the nucleus.
See, if I assume like this, right? Say there is whatever electrons are there. Now there is an incoming electron, and I'm going to add electron to this. Okay, so obviously it is favorable that the incoming electron has some kind of force of attraction, so that it can be easily added. Okay, right. Now same thing will happen for carbon also, right? But this attractive force which I have between the nucleus and the electron, in case of carbon, is not sufficient, as Sanyu told. Okay, it's not sufficient, fine. So if it is, okay, one way of looking at it is this is not sufficient, but the like say exact way of looking into this with respect to talking in terms of repulsion. One is attractive force. What is the other force? Obviously repulsion. Repulsion between what? Can you tell me at least that? Repulsion between what?
So maybe from the incoming electron and the existing electron.
Ah, very good, right? So obviously I already have 4 electrons present, right? I already have 4 electrons present, right? So the incoming electron, obviously it will have some kind of attractive force, right? But that is not the dominating force. The dominating force is the repulsion between the already existing electron and the incoming electron. Okay, so now you have, now last case, for you to remove electron, right? You have to supply energy for you to remove the electron to overcome the force of attraction between what? Nucleus and electron. Now in this case also, you have to spend energy to overcome the force of repulsion. Hope it all makes sense, right? Last time for removal of electron, you had to spend energy to overcome the force of attraction between the nucleus and the electron, right? But now you have to spend energy to overcome the force of repulsion between the existing electron and the incoming electron, right? Again, one electron adding itself is again difficult, but adding 4 electrons, again, because there's going to be a lot of energy spent. Okay, so now adding 4 electrons is also, the carbon is not going to go down the path because again, there is a lot of amount of energy spent. Right? So now what you have to understand, either the adding 4 electrons or removing 4 electrons is not a favorable process for carbon to attain stability. Okay, it has other ways of doing it, and that is what I wrote here, sharing electrons. Right? So now people, bonds in chemistry, right? When I say a chemical bond is formed, right? Please understand, bond is nothing but an attractive force. Okay, a bond, when I say, so many times we'll be using this, right? Bond, this bond, that bond, right? Bonds in general means there is some attractive force. Say I have 2 atoms, A1, A2, right? For example, say hydrogen, hydrogen, right? Now these 2 hydrogens are there. Now they are going to come together. These are hydrogen atoms, right? Now they are going to come together. So when they come together, there is going to be some kind of attractive force. We do not have to go into the details now. Okay, there is some, actually we can go into it. Let me explain it because it is going to be very helpful here. Okay, right. Now look at this people, right? Say, first, right? Now, okay, well, you understand that it is going to be an attractive force between the atoms. So obviously, I'm going to have some kind of attractive force between this hydrogen and this hydrogen. We will try to understand what is this attractive force? What is the physics behind this? Right? Now, please understand, bonds in chemistry can be of 2 types. One, we already know, ionic bonds. We have cations, anions. Right? So obviously I have a positive charge, I have a negative charge in a cation anion. Obviously I'll have a force of attraction. There is no doubt about it. Is it not? Say NaCl, NgCl2, Al2O3, whatever you have seen till now, right? All of them are ionic compounds. Basically I had a cation and I had an anion. Obviously, now you can understand in ionic compounds how this attractive force exists. Right? Attractive force exists because I have a full cation is positively charged, full anion is negatively charged. Obviously, it is natural for unlike charges to attract each other. That is understood. This is very easy to understand. Ionic compounds, right? Now, there is another kind of bond, or I would say ionic compounds or ionic bonds, we call it, right? Now, other kind of bond I can have in chemistry are what are called as covalent bonds. Okay, right? Another type of bond we can have in chemistry are what are called as covalent bonds. Here, there is no cation, there is no anion, right? So I would say in ionic compounds, there is going to be transfer of electron, right? Say I know cation has to lose electron, right? Now that lost electron will be accepted by anions. So anions accept electron. So there is an electron transfer from the cation to the anion. That kind of thing obviously happens, isn't it? Right? There is electron transfer happening. Transfer of electron is happening. Right? In covalent compounds, what will you see is that I'm going to have sharing of electron happening. That means the electron is not going out of the atom. It is going to be still inside the atom. That electron is not going to be only for that atom now. Right? Once the bond, so-called covalent bond is formed, those electrons are going to get shared between the two bonding atoms. Okay, two atoms are there. Right? Now there is going to be some electron shared between this, right? Not entirely transferring from this to this or this to this, right? There is going to be mutual, I would say it's better to say mutual sharing, right? What you have to understand is whatever one atom gives, it takes that. That means if, for example, if one electron is shared between A1 and A2, right? If there is one electron shared between A1 and A2 and A1 gives electron, A2 should also give an electron. Okay, A2 should also give an electron. So basically both of them will be mutually shared. These two electrons are shared between A1 and A2. And again, these two electrons are shared between A1 and A2. Hope you understand. Or I'll repeat again. The electron is coming from A1 is shared between A1 and A2. Same way, the electron is coming from A2 is shared between A1 and A2. This is what is called as mutual sharing. And this is what is called as a covalent bond. Right now, how do I understand this attractive force? Okay, sir. Now you are telling that there's going to be mutual sharing of electron. There is not going to be any transfer. Okay, I accept the fact. But where is attractive force coming? How is it that this kind of mutual sharing is able to make a bond? What kind of attractive force is there? Now it's very simple, people, to understand this. Okay, so now let us take a case where I have hydrogen. Okay, I have H2 molecule. I know hydrogen is a gas, O2 is a gas. All these are covalent compounds. Okay, we'll take a simple example, a H2. Right, now what you have to understand is H2 has a nucleus, say I'll call it as N1 nucleus, and it has one electron, say I'll call it as E1. Okay, right, now this is one hydrogen atom, say I'll call it as H1. Okay, now there is another hydrogen atom, H2, which is having a nucleus, say N2, and it has one electron, E2. Okay, right. Now, when these hydrogen atoms are very far away from each other, okay, very, very far away from each other, there is nothing happening. Hydrogen will be in the form of its atom. Right. Now, what I do is that I just bring them close enough. Right? I just bring them little push I give so that some kind of attractive force will come. Right. Now, understand, please answer this question. If I bring them closer, right? If I bring them closer, or I'll put it like this. If I just keep them in a position, one particular position, I don't have to do anything after that. They just keeps on moving together, moving towards each other and each other continuously. I'm not doing anything. Okay. All I did is I just put them in a position, one particular position. Okay. And they started coming together closer and closer and closer. Obviously because of the attractive force. Right. Now, can you tell me, looking at this, can you tell me what kind of attractive force can be between these two? There is no charge. I mean, there is no cation anion here, but still there can be some kind of attractive force. What kind of attractive force can you imagine here? Can you think of anything? When these two hydrogen atoms are close by, what kind of attractive force can I have between these two atoms?
Bond.
Sorry? What was it, Kanna?
A bond.
A bond, yeah, obviously a bond is going to get formed, but you have to tell me the physics behind this, right? I told you here, the bond is here. Why the bond is formed? Because this is a positive charge, this is a negative charge, so they're going to attract each other. That's what is the attractive force. Like that you explain here. What happens? Okay, nobody is able to think anything. See, both of them has nucleus, both of them has electron. Think about it. So when they are close enough, I'm telling you attractive force. Anything you can think of? No. See, the attractive force is going to be between the first nucleus and the second electron. Is it not very simple, right? This nucleus and this electron can have an attractive force because this is a positive charge, this is a negative charge. Same way, this nucleus and this electron can have an attractive force. Guys, accept it or not? Give me a yes. Yes?
Yes, sir.
Right? It's very
Yes,
simple
sir.
to understand, right? This I have a nucleus here which is positively charged. Now I have not the electron which is here, the electron of the next atom. Right? The electron of the next atom will come, right? The attractive force will be there. Same way, this nucleus is there, which is positively charged. Again, this electron is negatively charged. Again, I can have an attractive force. Right? This is the attractive force. I would say in covalent compounds. Right? The attractive force is between nucleus of one atom, right, and the electron of the other atom. They only have the attractive force. Right? They only have the attractive force. Okay, now let us bring you into the picture. Now I'm placing them in such a position that the attractive force starts. Right? Now the attractive force starts, that means the nucleus of one and the electron of other. The nucleus of this and the electron of this are going to get attracted. So they will come closer and closer and closer. Okay, now when they come closer and closer and closer, what happens is their shell itself modifies something like this. The shell modifies like this. Okay, now this becomes a H2 molecule. Now this is H1, H2 together. Hydrogen atoms are there. Now because of the attractive force, they came together and closer and closer and closer. They formed H2 molecule. Okay, now you see both the atoms got fused together. Okay, obviously you see the nucleus and the nucleus say N1, N2, right? And the electrons, there is mutual attraction here. The nucleus of this attracts this, the nucleus of this attracts this, right? So there is going to be mutual attraction so that the electron will get shared. These two are the electrons. Okay, up arrow, down arrow, something. You don't have to remember, you don't have to worry about this. This is nothing but the electrons that are there. This one, E1 and E2. Right? Now you see that is getting mutually shared between H1 and H2. That means it is going H1 and H2 means I would say H1 and H dash. That's better. H2 is a molecule. Okay, even I cannot call it H2 here. I'll call it as H dash. Okay, now this becomes a molecule. This is what is the basis. This is what is the physics behind a covalent compound. Okay, this is how mutual sharing happens. Okay, now obviously you see there is no charge development here. I do not require, I have to worry about octet, definitely. I have to worry about octet duplet. Here I would say, now see hydrogen is having one electron. This hydrogen is having one electron. But when it becomes H2, right, now both of these hydrogen would have had H2 electrons. Right, H2 and H2, both of them, because it is mutually getting shared. This electron and this electron are getting mutually shared between these two hydrogens. So duplet is satisfied. Okay, right? You might have learned about this Lewis dot structures in your 9th class. Did you study? Did you study about this Lewis dot structures?
No, sir.
Yes,
In
sir.
ninth? You might have studied, right? Now you know how to draw the Lewis dot structure. Hydrogen has one electron. This hydrogen has another electron. This hydrogen requires one more electron to satisfy its duplet. So it will take this, right? And this hydrogen requires one more electron to satisfy its duplet. It will take this, and that's it. This is what is structure. Now, please understand, for one covalent bond, 2 electrons are required. Okay, you understand here. See, there is 2 electrons, one pair of electron, one electron coming from one hydrogen, another electron coming from another hydrogen. They are mutually shared, right? Now this constitutes a bond. This is how we write it. Okay, so whenever I put a line in chemistry, this is a covalent bond. Okay, for each covalent bond, there will be 2 electrons. Okay, mutual sharing. One electron coming from one atom, another electron coming from another atom. Mutual sharing, and that's what we represent as a bond, a covalent bond. Okay, right now maybe if you all, I give you O2 as an example, right? Now O2, I know, like, see, you have to take, whenever you're going to draw the Lewis dot structure, you like the interaction, right? The interaction of electron is going to be from the valence electrons. Okay, I would say nucleus, what I wrote here. Nucleus of one atom and the valence electrons of another atom. That's what is the better way of putting into it, right? Nucleus of one atom is going to have an attractive force with the valence electrons of the other atom, and vice versa, right? Not every electron, okay, because that is what is little close by to the other nucleus, is it not? The inner electrons are little far away from the other nucleus, correct, right? So when I take O2 as an example, I know oxygen has 8 as the atomic number, 2, 6 is the configuration, right? Now you have to take only the 6. This 2 is not required now, because I told you only valence electrons are attracted towards the other nucleus, right? Right. So oxygen will have 6 valence electrons. Okay, 6 valence electrons. Another oxygen atom will again have 6 valence electrons. Right now, this oxygen requires 2 more electrons to satisfy its octet. Right, so it doesn't have to transfer electron for this, but this oxygen can take up this particular 2 electrons and get it octet satisfied. Now, if it takes up 2 electrons, it has to give 2 electrons because it is mutual sharing. You cannot just give it and get satisfied, get octet satisfied. That is greedy, and no element does that. Right. So now, if it gives 2 electrons, again, this oxygen atom also requires 2 more electrons. So in this case, you have, this is the Lewis dot structure. Right now, I told you, for one covalent bond, 2 electrons are shared. 1 electron coming from each. Right now, how many electrons are shared here? Look at this and tell me. How many electrons are shared totally?
4, sir.
4, is it not? 1, 2, 3, 4. Last bit was only 2 electrons. Right. So I would say in this case, there are going to be 2 bonds like this. So we write O, double bond O. Now, what do you mean by this double bond? That it means basically there are 4 electrons shared. One covalent bond, 2 electrons are shared. So two covalent bonds, 4 electrons are shared. Okay. Now, this kind of thing only this kind of stuff carbon does. Right? I know oxygen can form O2 minus, ionic compound. That is a different way of attaining stability. This is a different way of attaining stability. Is it not? Right? Again, I know H plus, H minus, all of them exist. But again, for hydrogen, this is another way of getting stabilized in the form of covalent compound. Okay? Right? So I hope everybody gets it. What do you mean by sharing of electron? What do you mean by a covalent bond? Okay? Now we understood that carbon cannot form ionic bonds because there is so much amount of energy requirement. Right? So obviously, all the compounds, the carbon forms, all of them are, where is carbon and its compounds they wrote? All these compounds formed by carbon are covalent compounds. Okay, are covalent compounds because of the energy required. Okay, right. Say, for example, we will take a simplest of a carbon compound. Right, simplest, right? The simplest one is my CH4. This is what is called as methane. right? The simplest of compound the carbon can form is what is my CH4, right? Now look at this. Can you, like, I'll give you, what is the time, right? I'll give you 2 minutes, people, right? I want the Lewis dot structure, how we wrote for O2, H2, right? Can you do like that for CH4? I'll give you 2 minutes time. Can you do this? And yeah, you can send me in WhatsApp after finishing. If you finished quickly, everybody take a pen and a paper, right? Draw the Lewis dot structure, how we did for O2 and H2, like that. You can do for CH4. Now remember, carbon is going to have 2, 4. You have to take only these 4 electrons. Okay, the 2 electrons you should not take. Again, each of the hydrogen atom will have one electron. There are 4 electrons, 4 hydrogens, like that. Yes, everybody completed? Okay, can I draw, or anybody needs more time? Okay, fine, I'll draw. Right. Say, now you see, carbon is going to have 4 valence electrons. 1, 2, 3, 4. Right? And there are 4 hydrogen atoms. 4 hydrogen atoms are going to have 1 electron each. Okay, now let us talk about hydrogen first. Hydrogen, this hydrogen requires 1 more electron to satisfy its duplet. So it will take up this electron. This hydrogen also requires 1 more electron. It will take up this. This hydrogen requires 2 more electrons. It will take up this. This hydrogen requires 2 more electrons. It will take up this. Done? Right. Now, carbon shared 4 electrons with 4 hydrogens. Right. So obviously it is mutual sharing. This carbon requires 4 more electrons to satisfy its octet. So it is going to take 1 electron each from 4 of the hydrogen atoms. Right. So you will see that there are going to be 4 bonds formed because there is 2 electron shared, 1 bond, 2 electron shared, another bond, 2 electron shared, another bond, 2 electrons shared, another bond. So you'll see that I'm going to have this kind of structure coming for methane. Right? Now you see, this is what do you mean by tetravalent. Right? There can be always carbon, right? Or carbon always forms 4 covalent bonds. This you have to always remember. Right? For each carbon atom, even if you have 1000 carbon atoms in a molecule, right? Or for all the 1000 carbon atoms, I will have 4 bonds associated with them. Right? Carbon always forms 4 covalent bonds. That is what you mean by this term tetravalency. Where do we write? How, what carbon makes so special? How do you, okay. Right? Tetravalency means 4 covalent bonds. That is what you mean by this. Okay, right? Now, why 4 covalent bonds and why not an ionic bond is understood, because I'm going to have removal of electron or acceptance of electron is going to take up a lot of energy. And this is going to be a less energy process. So obviously carbon will favor this only. Okay, fine guys, we'll stop with this for today. Any questions anybody has? Anybody wants to ask me anything regarding this or anything for that matter? Any questions anybody has? Something in the chat. Oh, you have sent in WhatsApp, Durlav. I'll see Kana. Okay, I'm sorry, I didn't see the message. Okay. Right. Anything else, guys? Anybody wants to know anything? Any questions? Okay. Thank you so much, people. We'll meet again next week. Okay. I'm ending the class.
Thank you, sir.
Thank you, sir.
Thank you, Shiv.
Thank you, sir.